NASA selects instruments for Artemis Lunar Terrain Vehicle (LTV). Today we talk about this news got out on the NASA website, and it's kind of important because let us understand and put some light, and this is the right word you will see, on the Artemis missions, Artemis program, and how they will look for water resources and, let's say, things on the lunar surface. So we're going to talk about for sure the main subject of today's episode, which are the three instruments selected to be tested within the program. For sure, not the only ones, but some of them. And then we're going to talk about some comparison with the Apollo program. I'm recording this episode on Thursday, 24th of July 2025. It's been a very few days, 3 days since we celebrated the anniversary of the first moon landing happened on the 20th of July 1969. With the Apollo 11, so it's a themed question to make a comparison with the Apollo program, some aspects of them for sure, and we're going to talk about also the moon region they're going to select for the exploration and for the landing, because you will see they can be and will be different for some kind of reason. So let's start. First of all, the three science instruments, which for sure are not the only ones selected by NASA for the Artemis program, for sure, but some of them. And before talking about the instruments, I'm spending a few words about the LTV, the Lunar Terrain Vehicle, which is a vehicle which will be tested and designed for the exploration of the surface of the moon. It will be partially autonomous and partially driven by astronauts. Well, I'm meaning that it can be only driven and only be autonomous too, so these parts are not strictly complementary, and it can switch 100% driven, 100% autonomous, and it will allow the astronauts to explore more easily the surface of our natural satellite. And it's important because distances can be covered much faster, exploration is for sure enhanced, and for some aspects it will remember and recall to your memory the rovers that you've seen like 50, 60 years ago. So let's start. Well, the first instrument is the IRIS, Artemis Infrared Reflectance and Emission Spectrometer. As the words say, it's a spectrometer which identifies and maps the minerals and, most of all, together with the volatiles. And minerals, okay, you guess it, they are rocks, basically, very basically defined as rocks, but volatiles are the molecules which are moving, I would say, freely and are not bonded within solid bonds among other molecules. And they can be, yes, you are thinking about the right word, water. And for example, so if you can capture and identify molecules of water, you can more easily identify the origin, the source of this water. Another instrument is the LMAPS, Lunar Microwave Active Passive Spectrometer, which is another spectrometer, this time developed by the University of Hawaii in collaboration with the JPL and the DLR, which is, for the people who don't know, the German space agency. And this will explore the moon's subsurface, including, for example, ice content, particularly water ice, the thermal properties and the solid structure of the subsurface of the moon. Well, I'm talking about subsurface, because you have to imagine that this radar, it's sort of, you can think about sort of a radar to simplify the concept, which is capable of scanning and under the crust, so the superficial surface of our satellite, and it's capable to scan and find out things, the properties of the solid material up to something like 40 meters below the surface. So it's kind of an interesting thing. And all these instruments for sure will develop technologies that we are going to use on Earth, but this is not the episode to talk about this. By the way, if you're interested about the technology which are being developed or have been developed primarily for space, and also I would say most importantly, the ones that people commonly think have been developed for space but actually are not, well, we have got a very interesting series here on the channel, here on Spotify, where you're listening, wherever you're listening at this episode, but also on our website, and most of all within our newsletter, which is for sure free. You can subscribe on our website, which is spaceinfo.club. We're going to debunk some myths, and it's very interesting, so it's free. You can easily access and read some very interesting content also by some experts. Another instrument is the UGSS, which will be the only, which will be in this group the orbital instrument. While the previous two will be mounted on the LTV, this one will orbit fly or soar basically the surface of the moon, and you can think about an instrument capable of giving you a very detailed map, regional map of the surface where you're going to explore. This is very interesting to give, very important to give context to your exploration. And well, now another important thing is, you guessed, something we mentioned at the beginning, and I told you it would be important. It's the location where you're going to land with respect to where you're going to explore. And I'm mentioning this because one thing that you don't have to underestimate is the contamination of the explored things by the explorers. So think about this. You're landing on a plateau, which is, let's say, and very understandably, one of the best conditions for landing. And yes, people buy intuitive machine. I'm talking about something happening to you like a couple of times. You need very flat, as flat as possible surface to put your pods on it and safely land without further complications. So this is a plateau, ideally, and maybe under this plateau there is water ice, which is also the subject of your exploration. But what happens when you land? Well, you're probably, for sure, there is no atmosphere on the moon, so you basically need retro rockets, and I would say, maybe comment down below if you are thinking about something else. I would say this is the only practical solution to land on the surface. So retro rockets. With the exhaust gases, you are contaminating the surface. The same surface and the same material you're going to explore with your instruments, with your spectrometer, for example, a few days, a few minutes after you land. So you're going to detect, for example, some hydrogen, some oxygen, because liquid oxygen and liquid hydrogen are probably within the exhaust gases. Well, you would conclude that you found water, hydrogen, oxygen, things like that, while you're just looking, at what you brought from Earth on the surface of the moon. So ideally, the South Pole is a very good location to land and to explore because of the conditions, because of what you're going to find, probably water ice, but also is not the ideal location to land because of the craters, the irregular surface. And there is another thing. Well, think about communication, something that we are going to talk about more deeply in some other episodes and also in some past ones. So give a look at them. And also the energy production. Nuclear energy is not a viable option nowadays, so you're probably going to use batteries which are recharged with the solar panels. But the South Pole is not famous for being a well-lit location, so Shadows are very long, the sun is very low over the horizon, and also the craters and the trough of the craters go very deep, and the sunlight doesn't reach well your point. Now you're probably thinking about how do you produce your energy, how do you communicate with Basecamp Earth. Well, you will find out in the second episode.